Hello students, this is the fifth ICGT lecture. Be attentive in the class. I am going to start within a moment. This is the fourth unit we are reading, and this is the last part of the fourth unit. Just a minute, I have lost the page, so I am again going back to the page. Just for a moment. Okay, we are coming to types of cooling system: air cooling, water cooling, radiator. You can see this water pump. Water pump is generally impeller type. You have read about water pump already in the earlier semesters. It draws the coolant from the radiator. Coolant means that is generally water with ethylene glycol, and it draws the coolant from the radiator through the lower radiator hose and forces it to the water jackets and then back into the radiator again. So what happens? Coolant comes in the upper hose of the radiator, gets cooled, comes to the lower hose, goes to the water jackets of the cylinder, and from there it comes back to the radiator. If the clutch fan can be wiggled up and down, most likely the water pump needs to be replaced. See, the clutch fan is again connected to the shaft which drives water pump also. So if the clutch fan wiggles up and down due to the rotation, erroneous rotation of the water pump, then the water pump may have to be replaced that case. Water pump gasket is placed between the water pump and the engine block to prevent leakage. Water pump and engine block are together, they are combined. So there is chance of leakage when two different parts are not bolt together. Then there is a chance of leakage in that, and so that it is not loose and it might not leak, a gasket is placed between, and then it is tightened with nut bolt and screw. There's the gasket. Water pump is driven by a crankshaft. You can see this is the water pump arrangement. You can see the arrangement. There is the power steering written here. That is the main power shaft. The main power shaft, you understand. The shaft which is rotated by the crankcase rotation. Crank rotation, I mean to say, the connecting rod and then the crank and the crank rotation, the main shaft connected, that rotates the power steering. Power steering is connected through the belt to the water pump. So the power is transmitted from power steering to the water pump. As the power steering rotates, the water pump rotates. From water pump it comes to alternator. That's an electrical part. That is also to be rotated for charge generation. We are not of we don't have much concern about the alternator. Then it comes to air conditioning. Air conditioning, what is the rotary part? Is the compressor. So this is rotating the compressor of the air conditioning. The compressor is getting rotated as a result of there is compressor up and down movement, and as a result of the compressor up and down movement, there is compression of the refrigerant. That's a different cycle, refrigerant cycle. But rotation is required, and that is done by the air conditioning pulley. That is the round structure you are seeing here. Then comes tensioner. Tensioner gives tension to the belt. So the belt doesn't become loose. It gives a tension to the belt, keeps the belt tightly fit into the grooves of the wheels. Then comes the cooling system. That is the radiator. In the cooling system, what are the rotatory parts? Generally the fan of the cooling system is the rotatory part, and the pump. The pump is being rotated already. So this is the part, the rotating cooling system is the fan is the part which is rotated by this shaft. So you can see the power shaft is the power steering. That's the main shaft from which the power is getting transferred through different shafts and coming back here. At each transfer of power, at each pulleys you are shown by a belt, there is decrease in power because of transmission loss. So you can see, starting from the first power steering to the last one, which is the cooling system, there is a large amount of power loss. So what is done? Which are the high power systems like water pump is placed at the nearest part of the power steering. Then water pump, then alternator, and then the air conditioning compressor. And at the last, the cooling system is kept because that is basically the fan which is rotating and requires less power. So at the last, the fan is kept. Try to understand the serial order in which they are maintained. First is power steering, then it is connected through the belt to the water pump pulley. Then water pump pulley is connected to the alternator pulley. Alternator pulley is connected to the air conditioning pulley. Air conditioning pulley is connected to the tensioner. And tensioner gives a tension to the belt. And from the tensioner of the belt, it comes to the cooling system. So, from beginning to the last cooling system, there is a large amount of power loss. So, the cooling system pulley will be able to take less load. That's why fan is given to it. But you remember, for each of the systems running with the power steering, this power steering is also connected to the wheels through the gearing arrangement. So, a lot of power is lost in these systems here. See, power steering power there is a fixed power generated by the piston cylinder arrangement. The more we distribute the power for other systems, the less is the output of the wheel. Our main intention is to get output at the wheel of the car. That defines the proper BHP of the engine. But the more power we divert to these systems, these accessories, like from power steering to water pump is to run the coolant, and water to the radiator, then to the alternator, and then to air conditioning, which runs the compressor, then the tensioner, and from the tensioner it comes to cooling system, where it runs the fan. So, to run these accessories, a lot of power is wasted. And so, the BHP at the engine outlet, that is engine outlet, what is that? The wheel movement becomes less as compared to what was expected to get. Now, the lesser these accessories draw power, more is the power we are getting at the wheel. And more is the power we are getting in the wheel, more is the output. And more output means more is the efficiency, because output by input is the efficiency. More is the input efficiency of the engine. So our intention is to reduce these accessories. Here I have shown all the accessories we are using in the car system, which are run by different pulley and belt arrangement. These accessory powers are to be reduced by some means so that the power obtained at the wheel is much more. This is not an easy task. You have to design the compressor in such an efficient way that the friction is lost. You have to design the radiator in such a way so that the pump which pumps the coolant through the radiator has a less head, that is the less friction it faces, so the pump power reduces. So the radiator, whole line of the radiator should be smooth. There should not be obstruction in the fluid flow anyway. So there are many things to be taken care of to run the system. You can see all these systems being shown here. These are very complex accessories here. This diagram defines the total accessories of the system. You can see that accessory belt, these belts, you must have read the belt and pulley arrangement. There is lot of transmission power loss between every two pulleys. And taking this system all together, a lot of power loss is there in goes to the system, and the rest of the power is transferred to the wheel. So the wheel ultimately gets less power. Then we come to the engine fan. The engine fan draws air through the radiator at low speed. That is a traffic. When you are at a high traffic, the speed is less, the engine speed is less, the heat generated is less. So the engine fan should run at low speed. That can be done by sensing the thermostat. The thermostat will up and down the speed of the fan depending on the temperature. When the engine temperature is less, you need not run the fan at higher speed. That saves a lot of power in the engine. I said you, the more you save the power in these accessories like cooling system, like air conditioning, all these alternators, all these accessories, जितना भी power consumption आप कम करोगे, you will get more power at the wheel. So when there is less temperature generation in the engine, that is when it is running at a lesser speed, at the high traffic, at red light and such other phenomena, that case the temperature generation in case of engine is less. So we can run the pump at lesser speed. Running the pump at lesser speed means less burden on the cooling shaft, the cooling pulley, the pulley which is doing that cooling system pulley is burdened with less load. Less load means this extra power can be transmitted to the wheel. So these are different things you have to this is a very intelligent balancing of the whole system. You have to see the whole system balancing in that, and from the whole system balancing you can go further. It slips at higher speed, in turn slowing the fan speed down. What happens? The belt slips from the pulley at high speed. When it slips from the pulley at high speed, it slows down. But it locks up at low speeds. At low speed, it locks up. Locks up means it gets tightly fitted in the groove of the pulley, and in turn speeds up the fan RPMs. As a result, the fan RPM increases. So this is another way of balancing it. Should be able to turn off when the engine is turned off. When the engine is turned off, the fan will also turn off. That is another important parameter of that. Then we come to the radiator. This is radiator, you can see. I can show you the radiator part. This is the radiator part. You can see there is an inlet through which the fluid comes inside. You will get more detailed diagram in next diagrams. Here is just a view of radiator. In the radiator, from the upper hose, and air fins are there. You can see air fins are there. Now, from the upper hose, the coolant comes within the radiator, and the lower hose it goes out. The coolant at the upper hose comes from the engine to the radiator. That means that coolant coming from the engine is hot. It has become hot after taking heat from the engine, and then coming to the radiator, it dissipates it, and then goes out after dissipating heat. It gets cooled because of the fan provided near the radiator. The fan passes air through the radiator. Air has air fins. Through the fins, the more heat transfer happens because of more surface area increase, and the radiator loses heat. The coolant loses heat. The radiator. As the coolant loses heat, it becomes cold. It becomes cool, and this cold fluid settles down at the bottom. So from the lower hose, it's being taken to the engine again. This is the cycle continuously going on. Remember, we have to recycle it because coolant is very costly. I told at the beginning of the class. So when we are recycle again and again, then the same coolant we are using and reusing, using and reusing. But it cannot go for lifetime, of course. There is a lifetime means you have a service period for every car. But every service period generally, after every servicing, they change the coolant. You have at first the 6 month servicing, then 1 year servicing, then 2 year servicing, and like that. And with every servicing, the coolant is to be changed. Remember that servicing is not done for extorting money from you. That is a wrong concept you Indians have. Servicing is done with the purpose that your coolant gets replaced along with other required parts. The same coolant you cannot use you again and again because there are so many dirt particles, dust particles, rust particles which get collected in the coolant because of continuous circling between radiator and the engine. So as the particles increase in number, performance of the coolant decreases. So you have to filter the coolant from time to time. Not coolant, you have to flush out the coolant. The coolant is flushed out and new coolant is put after a particular period. Coolant is quite costly. You people who are using car, you know that. When you change the coolant, coolant is quite costly. But that is to be replaced at a particular period of time, after a particular period of time. And that is used in radiator. Radiator is in front of you, you can see the air fins. Air fins, why? I said you, Q is equal to UA delta T. Q means heat transfer, A is surface area. Q is directly proportional to A. The heat transfer is directly proportional to surface area. By increasing the surface area, that is the air fins, we have increased the heat transfer. So the coolant loses more heat to the cooling air or the air which passes through the fan. This is one part of this parameter. Next we come to the basic cycle of radiator. Let me see how many. Let me come to the basic cycle of the radiator. This is the basic cycle of the radiator. In this basic cycle of the radiator, you can see this is the engine. This is engine. From engine, the fluid coolant comes in the engine, cools down the engine, itself gets heated. Coolant खुद heat up हो जाता है. That hot coolant comes through this outlet, goes through this pipe and comes through this inlet, enters into the radiator. This is the radiator. The lower part is radiator. You can see in engine, as the coolant gets hotter, it moves up at the top part and comes down and comes to the radiator because it is the hot part, comes to radiator, gets cooled due to fan in the radiator. And the cold part comes through the lower hose. This is the upper hose and the lower one is the lower hose. Comes through the lower hose, goes to this line, comes to water pump. Through the water pump, it comes to the engine again. It enters the engine at lower hose, picks up heat, gets heated, comes back at the upper hose and comes back. Now, high temperature thermostats are used here in the modern vehicles. If the thermostat is stuck open, the engine will run cool. That means this thermostat continuously senses temperature. If the thermostat sees that the more cooling is required, it senses it, the more cooling is required, that case it opens it. When it opens, more fluid will pass through it and come to the radiator from the engine. So that is thermostat open. When the thermostat finds that less cooling is required, let's say engine is running at low speed, less temperature is produced and less cooling is required, thermostat will gradually start closing the outlet from the engine. So the fluid will pass at lesser speed. As the fluid passes at lesser speed, less heat is transmitted to the fluid. So less cooling of the engine. You have to understand the engine will get cooled at different speeds in different way. At higher speed, the temperature generation in the engine is high, so the cooling should be more. So thermostat should be open. In lesser speed, in the higher traffic, say, or in case of red light, when engine stops, at that case, the temperature generated in the engine is less. So you don't need to run the fluid at high speed. So thermostat stops the speed. And automatically it the thermostat also senses in case of water pump, it stops the rate of the pump, the cycling of the pump. As a result of that, the fluid flow decreases. As the fluid flow decreases, the heat transfer decreases. And this is the way the whole cycle goes on. What is interesting, you were to look that natural phenomena of heat transfer is that in case of engine, it comes at the lower housing because the coolant is cool. Comes in the engine, picks heat, gets hot, and goes to the upper house. This is the top part of the engine, and there through the thermostat it comes back to the radiator and comes to the top part of the radiator. Why? Because the coolant is hot. So hot always comes at the top, cold always goes to the bottom. This is the natural cyclic phenomenon. We take the help of natural cyclic phenomenon. If we go against the natural cyclic phenomenon, which is the opposite the way it is given here, that case there will be more load in the water pump. More load in the water pump means our more power will be lost in these accessories. And the power lost will result in what? Less power in the wheels of the car, decreasing the efficiency of the car. So this is how the overall system is seen. And you have to understand this overall system in totality. These are the radiator, the thermostat, everything is working here. This is the way. You have to look at this way in this fashion. Now, efficiency, what I am describing at this stage, I am telling you, it is not only, I am talking only about the efficiency at the wheel, the power you are getting at the wheel. But actually, it is not only what power you are getting in the wheel. It is the power you are getting in overall. That means nowadays, when you run a system, run a car, you want a good air conditioning also, a good power also, a good radiator cooling also, a cooled engine also. You want everything. Now, the efficiency nowadays is defined as an overall efficiency. It is not only the power at the wheel. It is power at the wheel, power at the compressor of the cooling system, power at the fan of the radiator, power at the water pump of the radiator. There are so many things to be taken into account, and then the output is calculated. And then output by input gives you the efficiency of the engine. So it's in totality. But our basic view is that the maximum power, as much as we can, should be transferred to the wheel of the engine. Because ultimately, the main purpose of the engine is to carry you from one place to another place. So, if the engine doesn't have a good speed, it doesn't run at high horsepower, it cannot move through higher hills or steep hills. It cannot move through higher ups. It cannot take a high pickup. These all things are necessary nowadays in the car. When you compare the car statistics in the newspapers, you will see they will give everything: acceleration speed, the wheel speed, everything what you can have. So many out of so many parameters, the air conditioning part, this part, that part, that part, every part in totality matters in the efficiency. So the total output is divided into so many parts in the engine. It's divided into wheels, it's divided into air conditioning system, it's divided into water pumping system of the radiator, it's divided into the fan system of the radiator. Everywhere the pump is getting, the power is getting distributed. Now radiator pressure cap. We are having radiator pressure cap. This pressure cap is required to increase the pressure in the radiator. High pressure means high boiling point. And in case of radiator, the coolant should not boil. That's dangerous. There may be fire if the coolant boils. So what happens? The boiling point is kept higher. How the boiling point can be kept higher? By increasing the pressure in the radiator. How do we increase the pressure? By putting the pressure cap properly and pressurizing the system. It's written, each pound of pressure inserted increases the boiling point of coolant by 1.8 degrees centigrade. That is around 3 degrees Fahrenheit. We increase 1 pound of pressure, the boiling point increases by 1.8 degrees centigrade. Remember, water generally, the same coolant is almost like water with ethylene glycol in it. With water boils at 100 degrees centigrade. Water boils at 100 degrees centigrade. But if you increase the pressure, that is at atmospheric pressure, 100 degrees centigrade at atmospheric pressure. But if you increase the pressure, the boiling point increases. You have read in thermodynamics. So what we are doing in radiator, we are increasing the pressure, and as a result of that, the boiling point is getting increased. As the boiling point increases, as a result of that, the coolant inside does not get boiled. And then I said, in case of a radiator, there is an expansion tank. It goes to the extra fluid goes to the expansion tank. Extra fluid which comes in the radiator at the inlet. Say it is a very hot fluid. So whenever the fluid gets heated up, its volume increases. Where the extra volume will go? Radiator volume is fixed. Where the extra volume will go? For that, an extra tank is given. That is the expansion tank connected to that. So the extra volume will go to the expansion tank. It accommodates the heated up coolant in the expansion tank. When the fluid gets heated up, it expands. The volume increases. When the volume increases, the radiator. So what happens? If you open the pressure cap sometimes in radiator, you will see the fluid is bubbling out. Okay, you must have seen this mechanics opening the pressure cap of the radiator sometimes to release the pressure. At that time, the bubbling liquid tries to come out. You can see in the radiator in the engine. When they open it, it can be seen. Or even at the inlet of the radiator, if they open the inlet, very hot fluid comes out. That hot fluid, where you have to accommodate? You accommodate it in the expansion tank nearby, an expansion system. That's simple reservoir only. In that reservoir, the extra volume of fluid which gets expanded due to heating goes there and gets collected. And then top radiator hose brings the coolant back to the radiator. Top radiator hose means brings back to the radiator means there is the hot coolant coming from the engine comes to the top hose of the radiator because that is hot. I already described it. And are molded specially for individual make and model. Lower radiator hose draws the coolant into the engine. Naturally, the coolant gets cooled, comes down and settles at the bottom. So, lower hose takes it back to the engine. And this is the cycle continuously going on. With this chapter, we are going to finish the unit 4. This is my 6th lecture in row to you. I hope you have understood well. Any question you can ask on the chat box. You can call me also and you can ask you have any question. and I can answer you. Due to some problem in my laptop, I am not visible online to you, and so I am videographing this and putting it into the YouTube. You can always communicate through chat box. Thank you for attending the class.